In this video, we are going to discuss the SLD or the single line diagram of a substation. So we have here an image which is a design for an electrical substation of 66 to 11 kilovolt. As you know that, or as you remember from our course, that we said that the substation can be a step up or step down the voltage. So this substation is a step down substation. They are used to step down from 66 kilovolt coming from two different sources. It can be from an overhead transmission lines, or it can be from underground cables. So for example, here the substation 66 over 11, they are used to or convert the 66 kilovolt to the 11 kilovolt as an output. So let's see the construction here, or the single line diagram. First, we have here each of these lines, which is this part, and this one is an overhead transmission line of 66 kilovolt. This is another overhead transmission line 66 kilovolt. They can be from the same source or two different sources. Here we have the underground cables, okay, and this one is another underground cable. This one can be from the same source or two different sources. So this one used to provide a 66 kilovolt, and this one too, to a double bus bar. Double bus bar here, B1 and B2, since we have a two bus bar, it is called a double bus bar. And it is sectionalized because you will find here that the bus bar is divided into different segments. You will find this part is alone, and this part is alone, and this part. Okay, so let's see the construction of each part, or the benefit of each part. As we remember, overhead transmission line is exposed to lightning. So we have here a lightning arrestor, okay, made of horn gap. For example, it is used to protect our transmission lines from the lightning. They take the lightning and put it to the ground. So this is the first component, the lightning arrestor. Second component is the grounding switch. Okay, what is the benefit of the ground switch? When we turn it on, and of course everything is off, the circuit breaker here is off, the isolating switch here is off, the grounding switch takes all of the charges inside the transmission line and ground it. Okay, it is used to discharge any available charges in the transmission line. Why do we do this? In order to, in case of maintenance of the transmission lines. Okay, so we have to make sure that no charges is available on the transmission lines. So that is the benefit of the ground switch. There is also the isolating switch. This isolating switch is used for switching on and off. And of course it switches on and off at no load. Okay, then we have this part which is the circuit breaker. Circuit breaker is used for the protection against short circuit. Okay, we would like to protect our transmission line or our component against short circuit by the usage of circuit breakers, as circuit breakers used to protect against short circuit, which is made from the single line to ground faults, line to ground faults, symmetrical or unsymmetrical faults, and so on. So that is the benefit of the circuit breaker. As we remember that the circuit breaker is acting as the muscles, the one which is switch on and off during short circuit. Here we have this symbol which represents our current transformer. The current transformer is used for measurement and protection. It is used to step down the current inside the circuit in order to measure the actual value of the current passing or absorbed by our line. Okay, the current transformer is connected to the relay, which is the brain which controls the circuit breaker. So when the relay senses that the current exceeds the pickup current, the circuit breaker starts to switch off our circuit. Then we have here another isolating switch. You will find that our single line diagram is full of isolating switch to switch on and off the component. For example, if we switch on this part, then we are connecting this line or the overhead transmission line to the bus bar number 2. So it supplies power to bus bar number 2 only. If we close this switch, then it supplies power to this bus bar 2. Okay, so when this one is on and this one is on, then the overhead transmission line is giving power to bus bar number 2 and bus bar number 1. Similarly here, and of course for the underground cables, they can be incoming cables. They are providing power to the bus bar, or it can be outgoing. They are taking power from the bus bar and going out from the substation, okay, as a 66 kilovolt too. Now another thing you will find that we have here, this symbol represents the potential transformer, which is used also for protection and voltage measurements. You know that the potential transformer, as we discussed, used for step down the voltage inside the circuit in order to measure the actual value of voltage. And we have here the symbols which we have used: isolating switch, grounding switch, circuit breaker, current transformer, potential transformer, and the lightning arrestor. All of these components are said to be, they are called what? They are called switchgear. Switchgear, any component which is involved in the switching actions. The isolating switch is involved in switching on and off the circuit. Grounding switch is too. Circuit breaker is used to switch off the circuit during short circuit. Current transformer used for measurement, which leads in the end for switching on and off, same as the potential transformer. And the lightning arrestor, which takes the lightning to the ground. Another thing you will find that our bus bar is sectionalized. What does it mean? It means that this part, or the overhead transmission line, this one and this one, is providing power to these two bus bars. Okay, then we take from this bus bar to provide some loads, and this two bus bar is providing to this incoming or to this underground cables, provide power also to this bus bar 1 and 2, to this part only, and this one to this part only. If we have an error, or to be more specific, not called error, a fault in these cables, okay, we have here a problem and we would like to provide power to this part, okay, or to this bus bars. So in order to do this, we will have to switch off or switch on this isolating switches to connect these two bus bars. Therefore, the power provided by this component is to this bus bar and to this double bus bar. Okay, so the benefit of this, it separates between this part and this part, and in case of if we have a faults and would like to keep the loads here operating, then we will connect these two bus bars in order to provide power to them. The connection between them is done by something which is called a bus coupler. Bus coupler is also a circuit breaker, and we'll understand more about the bus coupler in the part we will discuss the 11 to 380 volt substation. So what happens after this? We take power from the bus bars, these bus bars and these bus bars, okay, and we have also current transformer, circuit breakers, and this power is a 66 kilovolt. It goes to a transformer, 66 over 11 kilovolt transformer, in order to step down the voltage, which is the benefit of our substation. Now the 11 kilovolt here is providing power to another bus bar. This bus bar is 11 kilovolt bus bar. And you see now that this transformer gives the power to this bus bar, and this transformer gives the power to this bus bar. This transformer gives to this bus bar, and this one to this bus bar. And you'll find something interesting. You will find that here we have a bus coupler. We have here another bus coupler and another bus coupler. And you'll find here cables. Each of them is 11 kilovolt. Going to a substation 11 kilovolt, or going to a transformer 11 to 380 volt, as we will see. So we'll find that each of this, which is 11 kilovolt, going to the thing which we are going to discuss in the next slide. But now you will find that this transformer is supplying power to this component, okay, and this transformer is supplying power to this part, and this transformer providing power to this part, and this transformer providing power to this part, okay, of course with all of its power below it, okay, all the elements here like this. So this transformer provides power to all of this until the bus coupler. This one provides power to this between it and bus coupler. This one provides to this 4 lines. This one provides power to all of this. Now in case of any of them having a fault, this one having a fault or something, then we will switch off our circuit breaker or make it an open circuit. Then the transformer will supply power to all of this, okay. So the bus coupler, same as here. Instead, if we have a fault here, we can connect these bus bars by bus coupler in order to provide power to the bus bar. Now we will find an additional thing. We said that here we have a 66 to 11 kilovolt, 66 to 11 kilovolt, and then going through cables, as we said before. But you will find something. You will find that we have here an additional transformers 11 to 380 volt. So what does it do? This one is called an auxiliary transformer, which provides a 380 volt, which is a line-to-line voltage. What is the benefit of this transformer or this transformer? They provide a 380 volt to the loads. Okay, the loads of the substation itself. The substation itself has a lighting. It has a components which works on electricity. All of this needs power. So where we can get our power? We simply take one of these cables and one of these cables here, and go provide it to a transformer, a step down transformer, to provide power which is suitable for our substation itself. Okay. So we discussed in this single line diagram the 66 to 11 kilovolt. So if we look at this one or this part, each of this is the output from the 11 kilovolt cables or from the 11 kilovolt substation. They are here from 66 to 11 kilovolt substation. Where does the 11 kilovolt go? They don't go to a substation, okay? They go to a transformer. A transformer's 11 to 380 volt. They have a definition called the kiosk. Okay, it is kiosk. This represents the transformers, which is a 380 to 11 kilovolt to 380 volt. So this transformer is a step down transformer, 311 kilovolt to 380 volt. Okay, so this is another step down transformer. So the 11 kilovolt cables go here and support or provide power to a bus bar called the distribution point. Okay, this bus bar, what does it do? It collects the power and then distributes this power. So that's why it's called a distribution point. So this bus bar, which is the 11 kilovolt, and this one is the cables. this is a 11 kilovolt cable, and this one is 11 kilovolt, and this one too. So these sources are from the same substation. Okay, this one are from the same substation, and this are from another substation. Okay, so in order to separate between these two substations, we put here a bus coupler. Okay, this one is 2 out of 3. Okay, so what does it mean? It means that if this one is working and this one is working, then this bus coupler is off. It is with this one and this one 2 out of 3. Okay, we have 1, 2, 3. Only 2 are working, which is the incoming cables here and incoming cables here. In case if we have a fault here, for example, a fault in this part, so we turn off our circuit breakers, or our circuit breakers will cut off the circuit, and then this bus coupler will be on in order to allow the power to flow here and to flow here. Okay, that's why this one and this one will work and this one is off. So it say 2 out of 3. 2 are working out of 3 components. Now if we look at this diagram also, you will find here we have these cables are providing power to the 11 kilovolt. Then from the bus bar we take the 11 and provide it to a bus bar. Okay, this bus bar supplying a transformer and 11 to 380 volt. Okay, and from the same bus bar we take a point, then we go to the next one, then from this one to this one, then from this one to this one, then from this one to this one, and so on. Okay, so what are we doing here? We are taking the main power 11 kilovolt and provide it to first one, then from the first bus bar we take it to the second one, and so on. So you will find that here, and connecting of course all of this here too. Okay, forming a loop. Okay, so you'll find that this and this one is connected to this one, and so on, and between them isolating switch. All of this is forming a loop. This is what's called a Ringman unit. But also to mention that you will find here that this one and this one of them are off. Why? In order to prevent the connection of this substation with this substation. Okay, so what is the benefit of the loop? If we are not connecting between them, then what is the benefit? The benefit is simply like this. Assume that we have a fault here. Okay, so this the circuit breakers here will act and turn off this line. Okay, due to the presence of a fault, and this isolating switch will be off. Okay, so we would like to provide power to this part. Okay, so in order to provide power to the 3 and 4, we provide power from 5 going through 4 and 3. How? By closing these switches. Okay, so the benefit of it is that in case of we have a fault here and we cannot supply power in this direction, then we can supply power to the loads here in this direction. Okay, so the benefit is that if we have here also a fault and we isolated the fault here, okay, we disconnected this switch and this one after the action of the circuit breaker. So we connect the or provide power from this direction to number 2 and provide power from here to number 3, and between them here is isolated. Okay, so that is what's called a loop. You can say that here this part can be from the same substation, or the loop can from here and going to another distribution point. Okay, it is not the same point. It can be the same point and it can be a different point. But anyway, it goes from a distribution point to another. It's called a loop, okay? Because we can supply power in this direction or supply power from the upper direction in case of the faults. So I hope you get some knowledge from this video about the substations. Don't forget to subscribe to my own channel for more videos about electrical power engineering, and check my own other videos about electrical power engineering. Thank you.